Welcome to the Walton Pi. Today we're going to talk about what it means for something to be a sigma algebra. So let's start off. When X is a set, any family F of subsets of X that satisfies the following three conditions, the empty set is in F, the union of any two elements in F is also in F, and the complement of any element of F is in F, is called an algebra of sets. If a countable union of elements of F is also always in F, then F is called a sigma algebra, or sigma algebra where they just use the Greek letter sigma. So anything that satisfies this is considered a sigma algebra or an algebra of sets if you don't have the countable union property. Okay, so let's look at some related definitions. For a set X and an algebra F over X, the pair X with F is called a field of sets. If F is a sigma algebra, then the pair XF is called a measurable space. And if we also include the measure that's defined on XF, then the triple XF mu is going to be called a measure space. So let's look at a couple examples. For a set X, the power set of X, in other words, the collection of all subsets of X, that's going to be a sigma algebra. This is called the discrete sigma algebra. It has all possible subsets, so literally everything is going to work out. We can also have the set that contains the empty set and X. That's going to be a sigma algebra. And this is called the trivial sigma algebra. And there's a whole lot of sigma algebras in between. Okay? Everything else is going to be somewhere in between these two. Okay? Now, a quick result that we can figure out is if we have a sigma algebra F over X, any countable intersection of elements in F is also going to be an F. So, let's say that U1, U2, U3, ... all of these are elements in F. And their complements, V1, V2, V3, ... are also going to be in F. Then V1 union V2 union V3, ... is in F because that is the countable union property. So any countable union has to also be in F. So that means they're countable unions in F. But then their complement is going to be the intersections of all the U1, U2, U3, ... And so that means that any countable intersection is going to be in F, which means that any countable intersection of elements in F is also in F, and we have finished our proof. I hope this was a helpful, really quick overview of what a sigma algebra is. In some of my other videos, I'm going to be going more in depth into certain types of sigma algebras, but those four requirements are all that is required for something to be a sigma algebra. I hope this was helpful. Please like and subscribe, it really helps me out, and if there's other topics you would like me to cover, leave them in the comment section down below. I hope you have a great rest of your day, and good luck with all of your math.